Hello students, welcome to another section of digital electronics. And today our topic is multiplexers. In electronics, multiplexers or mux is a device which is designed to select a single input between several digital inputs through select lines to a single common output. A multiplexer is also known as a data selector that is used to implement Boolean functions of multiple variables. Let's say there are 5 parallel tracks and let us assume that the train is running on the first track. There is a mechanism that is used to change between the tracks on which the train is currently running, say a lever, as it is used to park the train at platform number 2. So if we think there are n parallel tracks as inputs and the single parking track as output, then the lever is selecting one of the inputs and routing the train to the output. These devices are mainly used to increase the efficiency of the data that can be sent over the network within a certain amount of time and bandwidth. Multiplexers can be made out of universal combinational circuits. All the logic gates can be implemented with multiplexers. A simple representation of 2:1 multiplexer using NOT, AND, and OR gate is shown in the figure. Like this, we can implement basic gates to form a multiplexer. Here, I0 and I1 are inputs. A is the select line and Q is the output. The Boolean function of the circuit is as follows. Q is equals to A bar multiplied with I1 plus A multiplied by I0. Since the data in digital electronics is in binary form, the select lines are also in the binary form. For selecting from n inputs, we need k select lines. Therefore, we can justify that n is always in power of 2. The output line is always 1. Hence, the multiplexer is termed as n:1 mux. Therefore, if there is 8 inputs, then it is an 8:1 mux. For 4 input lines, it is 4:1 mux, and etc. Technically, multiplexers are not only used for data selection but also has a variety of use, that is, for realizing Boolean functions. Also, higher order mux can be designed using the lower order mux. Thus, the output generated by the OR gate is equals to I0. Similarly, when S is equals to 1, the output of the upper AND gate is 0. But the output of the lower AND gate is I1. Therefore, the output of the OR gate is I1. Thus, the above given Boolean expression satisfy this circuit. We have compared 2:1 multiplexer with 4:1 multiplexer with several parameters like inputs, select lines, circuit design and truth table, and output from Boolean expression. And also its symbolic representation. These are as follows. Now the waveform analysis. The graphical representation of the inputs, select lines and the output is shown in the figure. We can see that for several data inputs, the output changes according to the select line inputs as it clearly follows the Boolean expression of the system. In digital system applications, multiplexers finds its immense usage since this allows several inputs to be connected independently to a single output. These are found in variety of applications including data routing, logic function generators, parallel to serial converters, and etc. The DIP image of IC74153 is shown in the figure. This is an integrated chip of multiplexer. Now we have come to an end of this topic, and today we have learned the introduction to multiplexers, fundamentals and properties of multiplexers, how the multiplexers are formed, the Boolean expression of 4:1 marks along with 2:1 marks, the waveform analysis of a 4:1 marks, and the applications of multiplexers. We will meet again with another interesting topic of this segment, and till then keep watching and keep learning. Bye.